We'll try. I gotta get a pencil.
I lost mine.
We're allowed that too.
Yes, both of these.
Not that we're gonna lose that.
Good enough.
That's still use this.
Thank you, Mr. Ryan. Appreciate it.
Okay, like one of these, ish.
Yeah.
Alter line.
Oh, yes.
Assignments have been such a relief.
It's better than this.
How hard can it be? It's just, yeah, I know, no, I know, I know it's not. And then you start getting wrong.
Just don't go nice on this. Go into the test with your mechanical pencil and not have any extra lead.
The endless cycle of trading.
No, like I generally would
It was the test later, so I just walked in and said, hey, can I have a pencil?
Yeah, like I would try.
I always do.
They didn't get it.
Well, I mean, if it works, it works.
My calculator died last year.
Yeah, that's where I came from. Right?
Yeah, I'm gonna have to make sure.
Okay, so I think what we need to do today is we need to finish up talking about the binomial theorem and the applications of it. I think we just have a couple problems where we find the missing coefficient, and then we also have to go backwards from the series into the closed form. And then we'll spend the rest of the time today talking about what's on the examination, and then that way if you guys have some questions for me, I can answer those. Okay? And just as a reminder, assignment number 10, that's going to be due next Monday, and the exam's on Wednesday. Okay, so any questions before we get started, guys?
I thought exam is Monday because tomorrow is election.
What's that?
Tomorrow is election.
Unfortunately, election day is not a federal holiday, so we can stay open for that as much as we want. It's great. So, other questions, guys? Okay. So last time we went through, we went backwards, and we talked about what happens if we want the missing coefficient. Okay, and we did it for a fairly easy problem. Let's take a look at a couple more that might not be as easy. Okay, so I want to try to find the missing coefficient of the term a6b6 in the expanded binomial 3a squared minus 4b to the 9. Okay, so I think what we might want to do is we might want to identify a, b, and k in this problem. Okay. So if I was to ask you guys what a is, and by the way, we're using, when we say a, b, and k, we're talking about in the expanded form of the binomial theorem. So in this problem, what's a for us? 3a squared. It's the first term. Thanks. Okay. So we're going to say that a is represented by 3a squared. Okay. B would be represented by what, guys? Negative 4b. Okay, don't forget your sign there. Okay. And then finally, if I was to ask you what k is, what is k in this example?
9.
It would be 6.
Six.
What is 9, guys? 9 is n. Okay? But if we want k, we're looking for what's affixed to the variable b in this case, since b is minus 4b. So k in this case is going to be 6. Okay? Does that make sense to everybody, guys? Any questions about that? And clearly in this problem, n is none. I forgot to mention what n is, but n is probably the easiest thing to figure out. In fact, a, b, and n are all pretty easy. Okay? All right, easy enough, right, guys? Now we stick it back into the binomial formula. Okay, so we go back, and if you guys remember, okay, it's at the top of the page on the other side. This is your binomial formula right here, so we're going to utilize this. So we're going to say a plus b to the n is equal to n combination k, so that's going to be 9 combination 6. A, in this case, which is 3a squared, raised to the n minus k, or 9 minus 6. And then we're going to multiply that by b, which we said was minus 4b, this time to the k power 6. And again, all we're doing, guys, is we are substituting it directly into this part of the binomial theorem, except without the series, right? Because we just want that singular term that's in the binomial. Okay? Is that easy enough, guys? Any questions about that? The rest of the problem, we punch it in our calculator and we're done with it. Okay? So let's just go ahead and do that. Okay? Did anyone figure out what 9 combination 6 is by chance?
84.
In stereo. Thank you, guys. All right. So that's 84. And then this just becomes 3a squared to the third. So this is going to become 3 to the third, which is 27. A squared to the third, which is a to the sixth. And that's good news because we need an a to the sixth factor. And then we also need to figure out what 4 to the sixth power is. Well, negative 4, but it doesn't really matter since it's an even power. So did anyone figure out 4 to the sixth? 4096. Does that sound good, everybody? Okay. Thank you, gentlemen. 4096. And then b to the sixth is b to the sixth. Okay? So now all we have to do is just use our calculators, multiply 84, 27, and 4096. We get some horrific number. Okay, so was anyone able to figure out what the coefficient is for us?
928, 9728.
928, 9728. Okay. Is that Donnie's phone number? Did you get that on the bathroom wall? 928. Yeah, it sounds like it's about right. Oh, we forgot the 453 in front of it. Or I guess it's 976. Those were the chat lines, right? So I've heard.
1-900 number.
1-900, that's right.
It's an easy money right about.
Man, we're done. I think we need a hug, buddy. All right. Does that make sense, guys? All we're doing is we're just identifying these 4 characteristics and just throwing it back into the binomial formula. It's very easy, okay? Not meant to be different. Okay? It's a little bit sneaky sometimes, though, when the coefficient or the exponent power isn't necessarily, I guess, easy for us, okay? Especially with the k. In this one, k was fairly easy to identify, but if we look at the last one, it's not as easy, okay? So, I'm guessing everybody in this problem could figure out what a is, what b is, and what n is. But k in this problem might be a little more difficult than what you suspect. Okay? Let's do the easy stuff first, okay? Would anyone be offended if I said a was 5x squared, if b was negative y squared, and n was 5? Okay? That should be fairly easy for everybody. But I bet you I know what everyone's going to say. Well, I'll bet you I know what a lot of you guys would say what's going to k be. And a lot of you guys are going to say that k is equal to 4, because that's the variable, or that's the exponent of x to y. It is not 4. And that's kind of contradictory to what we've been thinking before, because we just look at the exponent that's affixed to the second factor, and we just throw it in there. So it's not. How come it's not 4? Well, first of all, what do you guys think it is, Steve?
Well, is it because the first factor is higher than the second one?
Okay, well, it doesn't necessarily matter which one's higher or lower than that. That's okay. But, John?
Is K2?
K is going to be 2 in this instance because we're looking for y to the 4th, and we need to make sure that whenever we apply the exponent to y squared, we get to y to the 4th. So basically we're saying y squared to what power is equal to y to the 4th? Or in other words, y squared to the k equals y to the 4th. All right? Now the only reason we didn't do that before was because the exponent was to the first power. But since the exponent's to the second power, we have to ensure that we get to the right one there. And John, you're absolutely right. It's actually going to be wind up being that k is equal to 2. Okay? Does that make sense to everybody, guys? It's because this second binomial term is squared. Okay? What if I was looking for, let's say, y to the 8th? Okay? What would k be if y was to the 8th power? 4. Okay? Because you would have to square y to the 4th to be able to y to the 8th. Okay?
Oh, okay.
Does that make sense, guys? All we're doing is we're just looking at this, and we're saying, what do we have to raise it to get to this exponent right here? Okay? So it's a little bit different than some of the other ones. Okay?
So if it was 8y squared, or multiply 2 times 4.
If it was y to the 8th, then k would have to be 4. If it was y to the 10th, k would have to be 5.
5, 12
okay?
will be 6, okay.
Right. Does that make sense to everybody,
Uh-huh.
guys? Okay. Once you have that, the rest of the problem's easy, okay? So just be careful when you start having these squared terms inside the binomial. Okay, so we set it up. We have 5 combination 2. Okay, so n combination k. It's going to be a to the n minus k, so 5x squared to the 5 minus 2. And then negative y squared, and since we said k was 2, that's going to be to the second power. And by the way, guys, if it doesn't expand and you don't get x6, y4, that's a clue that you've picked k incorrectly. I mean, figuratively, if you're sitting over there on the exam and you have no idea, I mean, you know I'm not going to give you guys n any bigger than like 9 or 10, so you can literally just sit there and do it 9 or 10 times. I mean, it might take you guys 5 or 10 minutes, but at least you'll get the right answer. Okay, so that might be my suggestion. If you have no idea how to do it, just beat it up, brute force it. Okay. All right, 5 combination 2, that's 10. 5 to the third, 125. X squared to the third, x to the sixth, so at least we know we're on the right track. And then negative y square, that's going to be a positive y to the fourth. So it looks like to me we get 1,250 as the coefficient, x6, y4. And I want you guys to notice that we did indeed end up with the correct exponential powers, x6, y4. Okay? By the way, I forgot to circle the actual answer for the last one. Okay? Because we're only looking for the coefficient. We don't care about the other stuff. Okay? Although I wouldn't be so cruel as to mark you guys wrong if you didn't circle just the coefficient. Okay. Oh, sorry guys. I didn't realize the computer was in some of you guys' way. Apologies. All right. Does that make sense, guys? Any questions about this? Okay? On your guys' exam on Wednesday, you guys will see something like this. Go home, practice a few of them. Look in the textbook if you need help. If you need some more problems, email me. I can pick some out of the text that's posted online for you guys. Okay. Another type of problem that we haven't looked at yet was what happens if I give you the series and I want you to go to the closed form of the binomial. Okay. So these aren't too difficult either. Okay. So I give you guys this series. Okay. K equals 0 to n combination k, 5 to the n minus k, and then 2 to the k. Remember what our binomial theorem says. If you can identify what A is and B is, you can just stick it back in and get a closed form. Okay? So if I was to ask you guys in this problem, what are A and B? Okay? Guys, what are A and B in this problem? 5 and 2, right guys? We don't need the exponents because we're just looking for A and B. So A is 5, B is 2. So really, wouldn't this series, because it fits the binomial series, wouldn't that just become 5 plus 2 to the nth power? In fact, it doesn't even matter what k is, okay? So some of you guys might have seen this binomial series in differential equations if your teacher was really difficult and gave you guys very, very difficult problems, okay? There's something called a binomial series that does arise on occasion in differential equations. You might have even seen it in Calc 2. Okay? But really, the k doesn't matter if it's in this form. So this just works out to be 7 to the n, which is much, much easier to evaluate than just going through and trying to figure out the sum of all those terms.
Why did you add them again?
Oh, because remember the binomial theorem? Let's go back to what the binomial theorem says. The binomial theorem says that if you have something in this form, okay, right here, which we do, it's equal to A plus B to the n.
Gotcha.
So all we're doing is we're just taking this and we're turning it into that. That's all.
That's considered closed form, right? That the
Correct.
side, that's
Yeah.
what closed form is.
Yeah, that's the much easier form to work with. Because now all you have to do is just plug in for n, right? That's a closed form or an explicit form where you just plug right in, okay? So let's say for some reason n was something like 55 and k was 33. You guys would have to do this problem literally 55 times and evaluate and add it. Or if you knew the closed form, you just stick 55 back in for n. Okay, that's all you would have to do with it. Okay, it's much easier to work with a closed form than doing that series. Okay, take a look at the second one, which doesn't look like it fits the binomial theorem, but it actually does. Okay? By the way, 7 to the n is the answer. So I did circle. All right. Now, a lot of you guys are looking at that, and you're like, okay, well, I can easily identify one of the two, either A or B, but I don't necessarily know the other one. So let's think about this, guys. In this problem, what do we have that's pretty apparent, A or B? We have B. B is what, guys?
15.
We can't get that one. Well, we could, but that would be perfect. So does that mean we can't do this problem, or can we identify done?
Multiply by 1.
Yeah, you can multiply by 1, right? Guys, could we say that this binomial series is exactly the same if I were to multiply by 1 to the n minus k, right? Guys, isn't 1 to the n minus k 1, no matter what the values of n are, right? Because 1 to any power is a multiplicative identity. Donnie, you're absolutely right. That a in this instance just happens to be 1 because it's an identity. Does that make sense to everybody, guys? If you're either missing A or B, just make it 1, okay? In fact, you could do the exact same thing if you guys didn't have either the A or the B in this. You could make them both into 1s if you really wanted to, okay? Now we just plug it back into the formula. We know that it's going to be 1 plus 15 to the n, which is going to be 16 to the nth power. Okay? Which I know you guys don't think of as easier to work with, but it's much easier to work with than that binomial series that exists there. Okay? Any questions, guys? Not meant to be difficult, just making it flip into a different form.
Would we ever need to go the other way and turn 16n into the series?
I could think of some scenarios that you would, but they're so, I just can't see it being used too often.
Okay, it's not really practical.
It's not
So
very
you wouldn't have to
practical.
worry about something.
I wouldn't worry about it, quite honestly, okay? The other way I could, like this way I could see being useful, but the other way I can't really see being too useful, okay? Unless like you have a really obscure problem that just happens to fit the binomial series, okay? All right, other questions, guys?